Okay, so continuing on with 2.4, this is 2.4b. Wow, that's bright, isn't it? Okay, 2.4b, continuing on, and we're going to jump into example 6. So what we're going to do here is we're going to use the distributive property first. So we're going to multiply 1/3 times x, and get 1/3 x, minus 4 times negative 4, or 1 times negative 4 is negative 4/3, plus 2x. Let's just put that over 1. Distribute that. 3 times 4 is 12. We don't do anything with the bottom number. If you remember multiplying fractions times whole numbers, you just multiply the whole number times the numerator and leave the bottom alone. Alright, so we've got that. What is the common denominator for this? Well, we have a 5 and we have a 3, so 15. So we'll multiply this minus 15 times 12 is 180 over 5 plus 45 over 5. Okay, so I multiplied that 15 times each one of these. Okay, all the way through. Alright, 15 over 3 is 5. And this is going to be 20. And we'll just take the fraction off, just make it 30. 180 divided by 5 is 36, plus 45 divided by 5 is 9. Alright, so let's see what we can do with this. We can take these two and add them together. And just leave the other side alone now. Now the smallest one is that one, so I'm going to move it over to the right. Get all my x's together. And I have negative 20 equals 36 minus 35 is 1x plus 9. And now I'm going to subtract 9 from both sides. And I end up with negative 29 on the left and just an x there. So that ends up being my answer here. So do you see why that works so well as far as getting rid of fractions? Finding the common denominator and multiplying the entire thing by the common denominator. Don't forget to multiply both sides of the equal sign by that common denominator. Alright, let's do the same kind of an idea with decimals. So I'm going to give you 0.08x plus 0.09 times x plus 2000 equals 690. Alright, so there's a couple different ways you can do this. One of the ways is to just do the math. 0.08x plus, and we're going to distribute that. And then we're going to multiply 0.09 times 2000. 0.09 times 2000 is 180, if you have a calculator handy, equals 690. Add those together. Leave everything else the same. Subtract 180. Those go away. 690, 590, 510. Kind of doing my math in my head out loud. And then 510 divided by 0.17, need a calculator for that, or the answer key, and you get 3,000. All right, so that works fine. Now let's go back to our original problem and show you another way to do this. And again, this other way is just a way that we use in order to get rid of the decimals so that we don't have to deal with them. So we follow the procedure pretty much like we did with the last one. And we're going to go ahead and distribute. Okay, so once we get rid of our parentheses, what we do is we see what place value our last number is in. It's in the hundreds here, and here it's in the hundreds. Okay, so if this is in the hundreds and this is in the hundreds, we can multiply the entire kit and caboodle by 100. And what that does is it moves the decimal place over 2. You don't have to do any math, you just move the decimal place over that number of zeros. So we're going to move that over 2. Move that over 2. Move this one over 2. So that means we add 2 zeros to it in order to move it over 2. And we do the same thing with the 690. Add 2 zeros to it so we can move the decimal place from here over to here and from here over to there. Okay? Now we just keep doing things as is. Subtract 18,000. Subtract 18,000. Those go away. 17x equals 51,000. Divide by 17, divide by 17, and our x is 3,000, just like in our last one. So nothing new there, or nothing weird there. We just moved the decimal places over so we didn't have to deal with decimals any longer. Alright, so let's do 2 more and we'll call it quits. So on page 124, we've got 2 identities, or definitions. One's called an identity. An identity is an equation that is true when the variable is replaced by any real number for which the equation is defined. And the definition for a contradiction is an equation that has no solutions. It will be a false statement for any replacement of the variable. Alright, so let's do example 8, and then we will jump to a contradiction for example 9. Okay, so this is an example of an identity. So let's just go ahead and do this one. Distribute. Distribute. Okay, let's get those combined. And these two combined. Okay, notice what happened here. That and that. If both sides are equal, then the equations are identical. So we can put any number in here for A, in here for A, and we're going to be equal. So if I just throw a number in here. Okay, 6 minus 10, 6 minus 10. I can put any number I want in here for A, here, and I'm going to end up with an identity. I'm going to end up with the same number over here as I do over here. Okay, that's not a 0, that's just a mark saying that whatever number is on the left I'm going to get on the right. So that's an identity, and sometimes you end up with those. Alright, so the next one is called a contradiction. Contradictions are they are definitely a real pain in the neck. And the reason for that is because you do all of the math correctly and you end up with a problem that just doesn't work. And then you've got to decide, is this a contradiction or did I do the problem wrong? And that's always a tough one, because if you know you did the problem right, you can say it's a contradiction. But how many times do we do problems like this and it's like, wow, that didn't work, I wonder if I did something wrong. So that's always something to think about. So let's distribute. Distribute here. So I am going to multiply the entire thing now, because I have all these fractions, by its common denominator. And the common denominator in this one is 6, because I have a 6, a 6, a 2, a 3, and a 3, and they all go into 6. And that gives me a 30x over 6 plus 18 over 6 minus 6 over 2 equals 6 over 3 minus 30 over 3. And now I can always reduce my fractions. 5x plus 3 minus 3x equals 2x minus 10. Alright, 5x minus 3x is 2x. That looks weird, because see, I have a 2x there and a 2x there, and I'm saying if I add 3 here, I will get a number, the same number as if I subtract 10. And we know that's not going to be true, but let's just keep going here. Let's subtract 2x from here and subtract 2x from here. And this disappears, but this 2x minus 2x also disappears, so now it says 3 equals negative 10. My x's disappeared, so I can't say x equals something, and all of a sudden I've got two numbers, 3 and negative 10, that are saying that they're equal to each other. And I know that's not true. So, no matter what value we put in for x, let's see, clear up here, we can put any number we want. This will not work. This side here will not be equal to this side. So what do you do for an answer? You have a couple options. You can make a real fancy parenthesis and leave nothing in it, which means the empty set. Or you can draw the cool little circle with the line through it, which is my favorite, which stands for the null set. Okay, either one is right, and they both mean there is no answer to this. Okay, so let's, looking here at the problem set for 2.4, and I am not seeing anything in here that we haven't already done. You know, you get into some like number 62 with some decimals. Don't forget that you're going to distribute that negative 0.3 times the 2x and times the negative 5, and then do the same thing with the 0.7 times the 3 and the 0.7 times the negative x. But other than that, those kind of things, there's really not anything really scary here. In fact, let's look at 62, negative 0.3 times. And if you're okay with doing these and you don't need the help, just go ahead and shut this video off, because I'm not going to do anything except this one here, so you're not going to miss anything. So we're going to multiply those two, and then multiply negative 0.3 times negative 5, and then I'm going to multiply this times this and this times this. So like over here on the right, we're going to get 2.1 minus 0.7x, and over here we're going to get 0.3 times 2, and we're going to get negative 0.6x plus, because we have a negative 0.3 times negative 5, 1.5. And that's pretty much it. You can either keep going with the decimals, or look and see, well, how, if I want to multiply this whole thing by something, what do I multiply it? That number and this number are 1 over from the decimal, so I put 1 0 there. So I get negative 6x plus, move everything over 1, and then I solve this as if the decimal, well, without the decimals, just like I normally do, and I'm good to go. Okay, any questions? Let me know. This is lesson 2.4.